Hi everyone, this is the second video for section 7.2, adding and subtracting decimals. So in the last video, we talked about using the base block model to add and subtract decimals. And so this time we're going to talk about the algorithms to add and subtract decimals. So what is the algorithm? So it's really similar to the algorithm that we had for adding and subtracting whole numbers in chapter 3. So we'll just kind of talk about it right quick. So the first thing that you need to do when you're adding and subtracting decimals is, just like before, write the numbers vertically. And in this case, we're going to line up the decimal points. So this is something that we're adding to this algorithm. When we talked about this algorithm in chapter 3, we didn't line up the decimal points because there were not decimal points to line up. Okay, we want to then, this is also new, append, which just means add to the end, add zeros so that the numbers have the same number of decimal places. So if we have one, for example, if we were looking at 3.2 minus 1.745, those have different number of decimal places, so we want them to be the same. Then we just add or subtract as whole numbers using the algorithms from chapter 3. And then lastly, we insert the decimal point in the sum or difference immediately below the decimal place. So this essentially says carry the decimal point down to the same spot. So insert the decimal point immediately below the decimal point in the numbers being added or subtracted. So it'll just go straight down. Okay, so this is all pretty standard. This is definitely something that you should know how to do at this point in your life. So one thing I just want to highlight about this algorithm is, why is the decimal point directly below the decimal points? Why do we have this carrying thing that we do? So the reason that we have this decimal point just going straight down. So think about it yourself. Pause the video before I tell you. Think about, why do you just, whenever you, for example, do 3.2 plus 1.7, well, we know this is 4.9, but why is it the case that all of these decimals just line up? So think about that yourself and pause the video to think about it. So the reason this happens is because of what we did in step A of our algorithm. So in step A of our algorithm, we line up the decimal points. And remember, I said that this was new in this algorithm, lining up the decimal points. So when we line up the decimal points in the first step, so in step A, we line up the place values. So when you line up the decimal points in the first step, essentially what we're doing is lining up the place values. So we make sure that, for example, again over here, so if we have 3.2 plus 1.7, whenever we line up those decimal points right on top of each other, we make sure that everything here in the 10th place is stacked vertically, and we make sure that everything here in the ones place is stacked vertically. And this is the case no matter what our decimal, like how many decimal places we have and how many places we have. It doesn't matter. This is the purpose that step serves. It's making sure all the tenths are lined up, the ones are lined up, the tens, the hundreds, and so on, either direction. So when we line that up, it lines up those place values. And well, we know that adding and subtracting doesn't change the place value. Right? Why would it? Why does adding 2 tenths and 7 tenths doesn't suddenly, instead of making 9 tenths, make 9 ones? That doesn't make any sense. And you can see this especially when you use the base blocks. Well, that whenever we add up here, when we add longs, we still get longs, right? and nothing changes. Sorry, let me think how to say this. The base block that we are using when we add 1 long and 4 longs and another 1 long, the base block when we add those things doesn't change. We may regroup if necessary, but whenever we add those longs, we still get longs. And so for that reason, you can kind of see that adding and subtracting doesn't change the place value, where those place values correspond to a certain block in our base block model. So because adding and subtracting doesn't change the place value, the placement of the decimal doesn't change either. So the placement of the decimal doesn't change either, right? When we add the tenths, when we add 2 tenths and 7 tenths, we still get 9 tenths. So it needs to be in the place immediately after the decimal. And when we add 3 ones and 1 1, we get 4 ones. So this 4 still is in the ones place, and this 9 is in the tenths place. So it doesn't change it. We still need the 9 to be directly to the right of the decimal, and we still need the 4 to be directly to the left of the decimal. None of that changes when we add things or when we subtract things. Okay, so this is actually all I have to say about algorithms for adding and subtracting decimals. You can see the rest of the page is empty. And that's because this, like I said, is something that I know that you all know how to add and subtract decimals. So I'm not going to show you a bunch of examples of that because I know that you know how to do it. I just wanted to talk about the algorithm and the specific things in the algorithm that just were a little bit different that you may not have thought of, why we put the decimal point directly below the decimal point before. So if you've read this section, you definitely have seen on pages 259 and 260 and 261, there's some things about using mental math and rounding, so the things from chapter 4, using those concepts with adding and subtracting decimals, more specifically adding and subtracting decimals using mental math, compatible numbers, and then rounding decimals. So we're not going to talk about that in the videos because it's just not as important as truly grasping the algorithms and the models and those things that reinforce what the meaning of these concepts are. So that's actually going to be all for section 7.2, and that's all for this video.